relationship between zeros and the coefficients of a polynomial. We discussed the second degree polynomial, the relations between coefficients and the zeros. Second degree polynomial is ax square plus bx plus c, and the zeros are alpha and beta, and the relations are the sum of the zeros is equal to minus b by a, and products of the zeros is equal to c by a. So you want to prove these results using algebra. So I write the general form: p of x is equal to ax square plus bx plus c, and I let alpha and beta are the zeros of this polynomial. Okay, so you know in 9th standard we have studied factor theorem of polynomials, and it says that if k is a 0, then x minus k will be a factor. If 2 is a 0, then x minus 2 will be a factor of p of x. Okay? That's what factor theorem in 9th standard we have studied. So here, if alpha is a 0 of p of x, x minus alpha will be a factor of p of x. And if beta is a 0 of p of x, then x minus beta will be a factor. Okay, so if you multiply the factors, the product will be a factor of p of x, and there can be some constant term also. So you can write the p of x as p of x is equal to x minus alpha into x minus beta. There may be some constant term. You can say as k or any other letter. Sometimes it may be 1 itself. So I simply denote by k. Okay. So in next step we expand this. You know how to do x minus y into u minus v. In 8th standard you have studied, right, these identities. Okay. So here we want to do x into x first. X into x is x square. Then x into minus beta. So that is minus x beta. And next is minus alpha into x. Minus alpha into x is minus alpha x. Then next is minus alpha into minus beta. So that will be plus alpha beta. Okay. And there is 1 into k. Into k is here. Okay. In next step, you can multiply k inside the bracket. So k into x square, kx square, and minus x beta into k. So minus x, so I shall write x beta as beta x. So k beta x, then minus alpha x into k. So k alpha x, then plus alpha beta into k. So alpha beta, okay, or k alpha beta. K alpha beta. So there's a chance in the middle term you can see that these two are x terms. Here x square term is kx square. This is constant term. K is a constant, alpha is a constant, beta is a constant. But in the middle both are x terms. They are like terms. So you can add this. So what will you get if you add minus k alpha beta x and minus k alpha x? Okay, k, you can take a kx outside the bracket. You can take a kx outside the bracket. Kx is common, right? So kx you take outside the bracket, minus kx. So what will be inside the bracket? Here from
beta
the first
minus alpha.
Yes, so we also took minus outside the bracket, right? So beta plus alpha. So in the first term minus k beta x, if you take minus k x outside the bracket, what remains? Beta remains. So beta plus, if you take minus kx from the second term, it will remain alpha only inside the bracket. Okay? Then plus k alpha beta. K alpha beta. Okay. In next step, what can you do is you can compare with the first degree general form. You can compare with the general form of second degree polynomial. Before that, we want to arrange one more thing. Kx square minus, you can write as the general form. So x comes in the end. Okay, so k times alpha plus beta. You can write beta plus alpha as alpha plus beta. Into x you can write here. So plus k alpha beta. Okay, so here compare the coefficients of this p of x and this. So here the coefficient is a, coefficient of x square is a, and here the coefficient of x square is k. So a is equal to k. We got a is equal to k. And the coefficients of x is b, and here coefficient of x is, what's coefficient of x? Minus k into alpha plus beta, coefficient of x. That is b is equal to minus k alpha plus beta. Okay. The next one is here c. C is the constant term. Now what is c here? Constant term here. C is equal to
K alpha.
k alpha beta. Okay. And from this you can make the results. So you substitute the k is equal to a in these two lines. So this will become okay. Shall write this here. So b is equal to minus k. For k you can write a because k and a are equal. So minus a into alpha plus beta. Okay. Next step you can take minus a into left side. So it will become b by minus a is equal to alpha plus beta. Okay. And you know 1 by minus 2 is equal to minus 1 by 2. So negative you can put here also, you can put like this minus 1 by 2 in common, no problem. Okay, so here we write like this minus b by a is equal to alpha plus beta. This is our one of the result. Minus b by a is equal to alpha plus beta. And from this, if you put k is equal to a, what will you get? C is equal to a into alpha beta. And if you move a to left side, you will get to c by a is equal to alpha beta. This is our second result. Okay, so alpha beta is equal to c by a, and alpha plus beta is equal to minus b by a. Okay, so this is the proof. Okay, so this is the relation between the zeros of a second degree polynomial and the coefficients of polynomial. Okay, so if a, b, c are the coefficients and alpha beta are the zeros, then sum of the zeros will be minus b by a, products will be c by a. Okay.
Sir,
Yes.
can you explain that proof again?
Okay. Okay, we can check the proof again. So the general form of a second degree polynomial is p of x is equal to ax square plus bx plus c. So we go to a and b and c, the coefficients. We assume that the zeros are alpha and beta. And in 9th standard, you have studied one important theorem about the polynomials, that is factor theorem. And the theorem says that if x minus k is a factor of p of x, then k will be a 0. And the reverse also, if k is a 0 of p of x, then x minus k will be a factor. Factor means what? If 10, we know that 2 is a factor of 10. So we can write it 10 is equal to some number into 2, because 2 is a factor of 10. Okay. So similarly, if k is a 0 of p of x, then p of x can be written as x minus k into something, because x minus k is a factor. Similarly, if 2 is a 0 of p of x, then x minus 2 will be a factor of p of x. Okay, so here we see that if alpha and beta are zeros of p of x, then x minus alpha and x minus beta will be factors of p of x. Factors of p of x, the given polynomial. So x minus alpha into x minus beta as some number. It can be a polynomial, first degree polynomial. The degree should be 0. It should be a constant number. Okay. So in next step, what we do, we take the product, we expand. So you know how to take x minus y into u minus v, at x into u minus x into v minus y into u plus y into v. And similarly, you do here, you will get this, and into k is outside the bracket. Okay, then you multiply k with each terms inside the bracket. So next step you can say kx square, then k into x beta, then k into alpha x, then plus alpha beta into k, that's k alpha beta. Okay, and now you compare with the p of x. So we have to make in the similar form. So x square term is here, that's fine, and the constant term is also fine. But for the x term, it doesn't look like a similar way. So we want to write the x term as a constant, then x. So what we want to adjust something. So here what we do, we take x, x and k are common in these two terms. X and k are common. So we take minus kx outside the bracket. Minus kx we take outside the bracket from these two middle terms. Okay, so inside bracket will be beta and alpha, beta plus alpha. We also took minus outside the bracket. Okay, so in the next step, to match with the general form, what we did, the x we write in the right hand. Okay, so it's a commutative property, right? So a multiplication commutative. So x you can write in the right or left, no problem. So x we write here. So now it matches with the general form. X square term, a constant into x square term, then a constant into x term, then a constant term. So compare with the coefficients. So here the coefficient of x square is a, and here these two are equal. So the coefficients must be equal. So here it is a and here it is k. So a should be equal to k, and here it is b, the coefficient of x, and here the coefficient of x is minus k into alpha plus beta. So we can write b is equal to minus k into alpha plus beta. Then we will substitute k is equal to a here. So then we will reduce the steps into alpha plus beta is equal to minus b by a. And also we can compare the constant term. Here it is c and here it is k alpha beta. So it should be, these two should be equal. So we write a c is equal to k alpha beta, and we substitute the value of k as a. So we'll get a c is equal to a into alpha beta. You move a to left side, so you will get a c by a is equal to alpha beta. Okay, so these two are the results.